Capital budgeting problems and solution. Illustration number 1. Company X is forced to choose between two missions A and B. Two missions are designed differently but have identical capacity and do exactly the same job. Mission A costs 1,50,000 and will last for 3 years. It, it costs 40,000 per year to run. Mission B 1 lakh and it has 2 years life and running cost is 60,000 per annum. These are real cash flows. The costs are forecasted in rupees for constant purchasing power. Ignore tax. Opportunity cost of capital is 10%. Which mission company X should buy? Okay, so let us solve this problem. Project A. So, what are the exact costs involved in the project A? Initial cost of the mission 1,50,000. 1,50,000. And then what is the additional cost? We have to convert into present value. So add a present value of additional cost because these costs are involved in between of the life of the mission. So at the end of the first year 40,000 and at the end of the second year 40,000 again and at the end of the third year 40,000. So we have to convert these 40,000 into present values by using present value factor. Add present value of additional cost. So additional cost per year is 40,000 for 3 years. Present value of annuity factor for 3 years at the rate of 10%. So 10% is the cost of capital. So we have to identify the cost of capital, present value of annuity factor. So present value of annuity factor at the rate of 10% of cost of capital. So life of the mission is 3 years. At 10%, 2.487. 2.487. We have to multiply this 40,000 with the 2.487. 2.487 and the present value of additional cost will be 40,000 into 2.487. It comes around 99,480. So total present value of outflows outflows that is 1,50,000 plus 99,480. It amounts to 2,49,480. So equivalent annual yearly cash outflows annual yearly cash inflows. Why we have to calculate annual yearly cash inflows, because in project A, mission A, it has 3 years life. In mission B, life is 2 years. So life disparity is there. So if you convert the outflow yearly basis, so how much is the yearly outflow? So that it is very easy to compare the projects, and you can judge the project which one is the best. So now we have to calculate equivalent annual yearly cash flows for the project B. Sorry, these are not cash inflows, outflows. So for project B, initial cost of mission, that is 1 lakh. So add present value of additional cost. So cost per year 60,000 for 2 years. So PV of annuity factor at the rate of 10% for 2 years, that is 1.736. PV of annuity factor 1.736. So present value of additional cost. Present value of additional cost is around 1,04,160. 60,000 into 1.736. Finally, total present value of cash outflows. That is 2,04,160. Now, equivalent annual yearly cash outflows. Yearly cash outflows, we have to divide this total cash outflows with the annuity factor 1.736. Now we will get the yearly outflow, that is 1,17,406. Sorry, 17,604. So explanation: initial investments are different, life is different, so we have to determine equivalent annual cash outflows, and it is recommended that project A should be selected because project A has less outflows when compared to the project B. So illustration 2. A company proposes to install mission involving a capital cost of 3,60,000. Life of the mission is 5 years and its salvage value at the end of the life is nil. The mission will produce the Net operating income after depreciation rupees 68,000 per annum. The company's tax rate is 45%. Net present value factors for 5 years are as follows. You are required to calculate the internal rate of return of the proposal. So, before calculating the IRR, we have to calculate the yearly cash inflows. So, first of all, if you just look at the problem, the depreciation we have to calculate. So, by following which method? I'm assuming calculation of depreciation So straight line method of depreciation method is followed while calculating the depreciation. So depreciation is equal to, so what is the formula? Investment by life. So 3,60,000 by 5, it comes around 72,000 per year. Now we have to calculate the cash flows per year. Here, here in this problem, net operating income after depreciation per annum, but before tax. So profit after depreciation but before tax, that is 68,000 less tax at the rate of 45 percentage, that is 30,600. Therefore profit after tax $37,400, add depreciation 72,000, cash flows per year. One lakh 9,400. So now calculation of IRR. Here, cash flows are uniform in nature. So, step 1 in calculation is calculate the fake payback period, that is 3,60,000 divided by annual cash inflows. 3.291. So, step 2, find the payback period. Find the payback period in present value of annuity factor. Present value of annuity factor table in what is the life? 5 years. In fifth year row. So, fifth year row annuity table, we have to find the payback period, that is 3.291. At 10% is 3.791. Okay, 3.291. So, this payback period lies between 15% and 16%. Now, we have to calculate the net present value. So, the figure lies between 3.352 and 3.274 at 15% and 16% respectively. So, step 3, calculate NPV for both discount rate. So, both discount rates. So, NPV at the rate of 15% and NPV at the rate of 16%. So, present value of so cash inflows, yearly cash inflows are 1,09,400 into present value factor 3.352. 3.352 minus 3,60,000. NPV is 6,709. So at 16 percentage, NPV is, so annuity factor will be different, 3.274, and we have to deduct the PV of outflows, that is 3,60,000. So NPV will be minus 1,824. So the exact NPV lies between these two percentages. To interpolate these two percentages, we have to use this formula. IRR is equal to lower rate plus NPV at lower rate divided by NPV at lower rate minus NPV at higher rate into the difference between higher rate and lower rate. So we have to substitute the values. So lower rate is 15 percentage. 15 plus NPV at lower rate divided by NPV at lower rate minus NPV at higher rate. So NPV at higher rate is already in minus. So minus into minus plus. So the difference, we'll just mention the difference also. Minus into minus plus comes around 8,533. So 6,709 divided by 8,533. So the difference between 16 and 15 is 1 into 1. So nothing. The result will be 15 plus 0.78786. So IRR is 15.786 percentage. So at this IRR, NPV is 0. So next, illustration 3. So management of a company has two alternative proposals under consideration. Project A and project B. So project A requires 12 lakhs outlay and project B requires 18 lakhs. Both are estimated to provide cash flows for 5 years. So 5 years is the lifetime. Project A 4 lakhs per year and project B 5 lakh 80,000 per year. So cost of capital is 10%. Show which of the two projects is preferable from the viewpoint of net present value method, present value of index method, profitability index, that is, so internal rate of return. The present values of rupees 1 of 10%, 18% and 20% to be received annually for 5 years being, so these are the present value of annuity factors of these respective percentages, respective cost of capitals. So we have to decide which project is a benefit, which project gives benefit by using the, we have to tell our decisions by using these techniques and which one is preferable according to these techniques. So let us prepare a statement showing calculation of NPV and PI. Method, particulars, project A and project B. Method is NPV, first method. So particulars, what is the formula for NPV? PV of inflows minus PV of outflows. So PV of inflows, we have to convert the annual cash inflows, that is 4 lakhs, into present value at 10% discount rate. So 4 lakhs into at 10% annuity factor is 3.791. 3.791 minus PV of outflows. Outflows are 12 lakhs. I am using the word present value of outflows because today we are investing 12 lakhs. In the sense, present value factor for 0 year is 1. So if you multiply 12 lakh with the 1, so it comes the same value. So present value of inflows 15 lakhs 16,400 minus 12 lakhs. So net present value is 3 lakhs 16,400. So for project B, same procedure. 5 lakh 80,000 into 3.791 minus 18 lakhs minus 18 lakhs. So present value of inflows minus present value of outflows. So it comes around 3,98,780 as NPV. So now the method is profitability index. The formula for the profitability index is PV of inflows divided by PV of outflows. So that is 15 lakhs 400 divided by 12 lakhs. Divided by 12 lakhs. So it comes around 1.26. For project B, it is same, 21,98,780 divided by 18 lakhs. So profitability index will be 1.22.